Memory management is often overlooked until your React Native app crashes. As your app grows, memory leaks. Bloat and native crashes can creep in silently. In this video, we'll dive deep into how React Native handles memory, common pitfalls, and how to diagnose and debug native crashes on both Android and iOS. React Native apps run a JavaScript thread that communicates with native modules. This bridge can cause memory pressure if not handled properly. For example, large arrays, images held in memory, or unnecessary re-renders can silently eat up RAM. The first step is awareness, knowing that mobile memory isn't infinite. And poor management leads to crashes and App Store rejections. Start with memory monitoring on Android. Use Android Profiler in Android Studio. It shows heap usage, memory allocation, and garbage collection events. On iOS, use instruments with Xcode, specifically the Allocations and Leaks tool. These help visualize what's being allocated and when it's being released. If your heap usage climbs and never drops, you've likely got a leak. Images are a top memory killer. React Native doesn't automatically unload them. Use libraries like React Native Fast Image for better caching and unload strategies. Avoid keeping large bitmaps in memory. And be mindful of ImageBackground components. They can silently consume megabytes of RAM if used carelessly. Memory leaks often come from holding onto references that should be released. This happens when you use timers like setInterval, subscriptions like addEventListener, or retain large closures without proper cleanup. Always clear intervals in useEffect. Unsubscribe from listeners and avoid retaining data across unnecessary renders. Use useRef wisely, it doesn't trigger re-renders, but it can keep objects alive forever. On Android, native crashes usually leave a trail in Logcat. Look for fatal exception or SIGSEGV entries. On iOS, check Xcode device logs or crash reports in Organizer. If the crash mentions RCT bridge or memory address violations, it's likely a memory overflow or an invalid native call. Also review stack traces for C++ or Java/Objc methods failing unexpectedly. To get full crash reports, integrate tools like Sentry, Firebase Crashlytics, or Bugsnag. They capture JS and native stack traces, device context, and memory stats. You can see exactly which screen the crash occurred on, what the memory load was, and which line of code triggered it, saving hours of guesswork. Another powerful approach is to use heap snapshots. Both Android Studio and Xcode instruments allow you to take memory snapshots and compare them over time. If a component is supposed to unmount and doesn't free memory, you'll see retained objects in the snapshot delta. This helps identify orphaned objects and rogue memory usage. Be proactive with optimization. Use flatlist or flashlist with proper key extractor. Avoid unnecessary re-renders with React. Memo and trim state shape to what's needed. Also profile your JS bundle to eliminate bloated third-party libraries. Remember, every megabyte counts on mobile. In summary, memory management and crash debugging aren't glamorous, but they are essential for performance, user trust, and App Store success. The best apps don't just work, they survive under pressure. Want a crash reproduction demo or heap analyzer walkthrough? Drop a comment and let me know.